So this video is looking at SOH CAH TOA. SOH CAH TOA. If you like, it would be quite helpful to pause the video right now and memorise SOH CAH TOA. I'm going to tell you what they mean and how they link in with our right angled triangles. And yeah, it's really just something to memorise and know how to use, how to apply to your triangle. So here's our triangle that we're going to use. We're going to give the angle theta as that one down the bottom there. From previously, there's our right angle. From previous video, if you're following from the Physics Lounge website, you would have seen the hypotenuse is here. That's the side that is directly over from the right angle symbol. And the side that is opposite to the angle that is provided is the opposite, and the side that is adjacent to the angle provided is the adjacent being next to. Okay, so what you might have realised is that the O's and the H's and the A's link to these sides here. This is why we learn those names for the sides, because we're going to need to identify what we have so that we can identify which of the SOH, CAH and TOA we have. So I'm just going to write out the full, these are equations. I'm going to write out the full equations for you so that you can sort of see how it works. There's alternative ways of writing SOH CAH TOA which are a little bit more helpful. But as long as you start off remembering SOH CAH TOA, and I'm saying SOH CAH TOA over and over so that you will remember it, then you should be right. So SOH stands for sine, which is a button on your calculator that just does a function. It's a little bit like squared or square root or log or something like that. They're just, as far as you need to know, keeping it really simple, it's a function that modifies theta. Okay, there's theta over here. So we've got the angle. If you press your sine button in theta, it's going to give you a number which links to your other parts of the side, and it helps us to find out unknown values, which is again what all equations are about. So sine theta equals opposite, okay, the opposite side, the O, over the hypotenuse. Okay, so that's where the OH comes from, the O and the H. We can abbreviate this, and we usually write it as sine theta equals O over H, opposite over hypotenuse, and that's the form that we'll use if we're ever doing a calculation. Okay, so what does that mean? Just explaining it even a little bit more detail. It means if we use the sine button on our calculator, SIN stands for sine. Sine is actually SINE, but let's just go with it. If we press the sine button on our calculator and then put in that value for the angle, press equals, it's going to give us a number, and that number is equal to the opposite divided by the hypotenuse. Okay, so let's do a specific number. I haven't got one prepared, but I'm going to, where are we? Move this out of the way. Specific example in green, and your right angle triangles don't always have to be of this orientation, they could be rotated, but if we have our angle theta, and this is going to be length 3, this is going to be length 5. This is a special triangle, but I'm not going to worry about putting the angle in. You'll come across it and you'll go, aha, if you know what I'm talking about. Anyway, going through the whole process, this happens to be a sine one because we've got the hypotenuse and we've got the opposite. So if we were to very quickly go to our SOH CAH TOA, the way we choose which of these to use is by what we have. So we've got the O and the H. The only one out of these three that has the O and the H is the SOH. So we would write then sine theta equals opposite over hypotenuse, which in this case, sine theta equals 3 over 5. So when you, whatever the angle for theta you get, if you use sine to modify it, that number, whatever number it equals, is going to be equal to 3 over 5, which is 0.6. So that's where it's linked in. Now we get a little bit more complicated rearranging these, and there's a separate video for that using the formula triangles specifically to show you how to rearrange them. Okay, what I want to do now, I've given you one example. I want to go through and just draw the other two equations, and then excuse me, and then we'll maybe give you one more example to finish with, so you can see a pattern of how it starts to work. So if we look at our CAH now, CAH stands for cos theta equals adjacent over hypotenuse. So where's our triangle down the bottom there? This time it's the adjacent over the hypotenuse. So this would work if you didn't have that opposite side. Okay. The other one we now have is our TOA. Stands for, trying to be consistent with my colours, tan theta, and cos is cosine and tan is tangent, but tan theta equals OA, opposite over adjacent. Opposite over adjacent. So that works really well if you don't have the hypotenuse. So if you're missing that one and you've only got these two and the angle to link together. So that's very helpful. Pythagoras will come in a little bit later, but if you've got two sides of a right angled triangle, you can always find out what the third side value will be. And that might make it a little bit easier if you ever have to work with angles and you're trying to minimise the amount that you're learning. But better to learn your SOH CAH TOA in completeness and your Pythagoras in completeness, two very essential tools to using your vectors. Okay, so one final example, similar to the sine example I did before. And again, the beauty of a video, you can replay it if you're not sure how it works. So I'm going to come over here and we'll use tan for an example. Red triangle this time. There's my 90 degree. And I'm going to stick with the same values here. We've got, what have we got? I'll just do it this way, 3, 4, and theta. So I have my adjacent side, my opposite side. That means I can use TOA because I've got that opposite and that adjacent. So my equation is going to be tan theta equals opposite over adjacent, which is tan theta equals 4 over 3. And that'll, so whatever you multiply, use that tan function on for the value of theta, that'll be equal to 4 over 3. And there you go. I haven't done a cosine example, but you should have the gist of it and work out now. Summarising really briefly again, you look at what sides you have, and then you go to your SOH CAH TOA to decide which ones they have. So each of these, this has opposite and hypotenuse, this has adjacent and hypotenuse, this has opposite and adjacent. So each of them is missing one. Sine is missing the adjacent, cos is missing the opposite, and missing the hypotenuse for tan. So you can only use each of them in a certain situation. You look at what you've got, you decide on the equation you need to use, you write the equation out, and then you proceed with your calculation. The proceeding with the calculation we'll look at in the next step. Yeah, hopefully that's helpful for you. Again, watch it if you're not sure. This is essential for your physics in level 2 and up.